All right. This next factoring method is factoring without a greatest common factor present. So the advantage of this is that it can be applied to an expression with many terms. Another advantage is it's useful when it's necessary to reduce the coefficient of x to 1, such as when graphing the reference form for square or cube roots, reciprocals, and trig functions. The disadvantage of this factoring method is that it creates fraction coefficients and constants. We all love fractions. Um, so this idea that can be applied to many terms, okay, I've given kind of side-by-side examples of how it's used with a two-termed expression versus a three-termed expression, okay? Um, so the goal is to be able to factor the leading coefficient out. And this is given that the coefficients of the other terms have no common factors. All right. So the first step, given this is our expression, we want to be able to factor out an a out of this. But b has no factors in common with a. So what do? What you do is you take this b term and you multiply it by a over 1 and its reciprocal 1 over a, right? Because the product of these two is going to be 1, right? The a's will cancel and you're left with just 1. All right, so multiply every other term by a and its reciprocal. Effectively, this is multiplying by 1. Okay. Then what you do is you'll notice now this first term has a in it, and the second term now has a in it. So you can now factor out a from both terms and put it on the outside. And then what do you have left? Well, we have x in this first term. And in the second term, we now have b times 1 over a. And you'll notice now this term, x, no longer has a coefficient. It had a as a coefficient, but now that a is gone. That a is now outside. It's been factored out. And the third step is just to clean up. So we can write b times 1 over a as b over a. And when you apply this process to, a longer expression, one that's got more terms in it, right? So let's say we want to factor out this a, then we multiply the next term times a and its reciprocal. And then we take the next term and we multiply it by a and its reciprocal too. So we're just kind of, applying that process on down the line to the other terms in the expression. And then since every term now has an a in it, you can now factor that a out of every term. And when you clean this up, you've got a factored out. This x squared no longer has a leading coefficient. And now the coefficients in front of these other terms are b over a and c over a. So let's do an example and see how this kind of works out in the wild here. All right, so what we want to do is we want to be able to factor this 2 out of this expression within this trig function. So we have a cosine of 2x plus 3, and we want to factor a 2 out of this 2x plus 3 expression. So how do we do that? Well, we're not going to do anything with cosine. We're going to leave that alone. Okay, and then we're going to have 2x. So in this case, a is 2. So now the next term, 3, we're going to put plus 3. We're going to multiply that times 2 over 1 and 1 over 2. Just like that. Now the next step, notice now that both of these terms have a 2 in them. So I'm going to factor out that 2. And what do I have left? I have x plus 3 times 1/2, like that, which is going to be the cosine of 2 times x plus 3/2, just like that. All right, you don't know this yet, but being able to do something like this will be helpful later when we're graphing trig functions. All right, so this is one way you can do it, where you can see this in the wild. We have this think, pair, share here. So go ahead and pause the video and give this a try. All right, but let me go ahead and let's work on this. All right, so in this case, our leading coefficient is 3, which means these other two terms we're going to multiply by 3 over 1 and 1 over 3. So we've got minus 5x times 3 over 1 times 1 over 3 plus 7 times 3 over 1 times 1 over 3. Remember, these two multiply together, cancel out, and are equal to 1, just like these two. So we're not actually changing the value of our expression just by multiplying these terms by 1. But what we have done is now we've got 3 terms in this expression, and each term now has a common factor, a greatest common factor that we can now factor out. So that 3 can come out, and what we've got left is x squared minus 5x times 1/3 plus 7 times 1/3. And we can just continue to simplify this. So we have 3 times x squared minus 5/3 x plus 7/3. And again, this is what I referred to earlier about the disadvantage is that it creates coefficients and constants with fractions. But, if your goal was to, maybe factor out a 3 that you need to cancel with something else, if you're going to multiply something by 1/3 and you need to cancel the 3's out, okay, this is a way you can do it. All right. All right. So that's it for this factoring method. Let me know if you have any questions.